Today we shall be talking about the screws used in the orthopedic. There are two types of screw, wooden screw which is used in the wood and the machine screw which is used in the machine. The difference between wooden screw and the machine screw. Wooden screw is used in wood and the machine screw is used in metal. It has larger threads and are usually tapered. Wooden screw has larger threads are the larger, and it is usually tapered. But the machine screw has a small thread, and it is cylindrical throughout. It is not tapered like the wooden screw. For the wooden screw, pilot hole is a small. Pilot hole is a hole created at the site of intended screw placement through which screw is passed. And pilot hole for the machine screw, the pilot hole should matches with the size of the screw core. In wooden screw, hold is because of the elastic force from deformation of the wood. As wooden screw is used in the wood, the hold is because of deformation of the wood, and in the machine screw, hold is because of elastic force from deformation of the screw itself. Hold is due to deformation of the screw itself, and in wooden screw, hold is due to the deformation of the wood. And the wooden screw are intended to place in which threads are not cut, but the machine screw is intended to place in a hole in which threads have already been caught by a tap. As the wooden screw is used in wood, threads are not caught. Now, the bone screw. The bone screw is the modification of either the machine screw or the wooden screw. Bone screw is the metallic implant which convert the rotational force into the linear motion, and bone screw is inserted into the bone for the purpose of internal fixation. Bone screw is used either alone or in conjunction with other implants. Bone screw has four functional parts. This is the head, shaft, which is also called shank, the thread part, thread, and the tip. In head of the screw, bone screw, it has two components, recess and the countersink. Recess is the slot on the head of the screw which provide place for the screwdriver attachment. But countersink is the under surface of the screw head which prevents sinking of the screw into the bone. Various types of recess exist currently. Used are two. Hexagonal, this is the hexagonal, and the star drive recess. And the various types of countersinks are available. Currently used are non-threaded, which are used for cortical and the cancellous screw, and the threaded, which is in the locking screw. In the locking screw, the countersink is also threaded, but in the cortical and the cancellous screw, this countersink is not threaded. Functions of the head. Head provides place for the application of twisting force to the screw through the recess. It acts as a stop through the countersink. Now the shaft. This is the shaft, which is the non-threaded part between the head and the thread. This is the threaded part, this is the head, and the shaft. Shaft is between head and the thread. Shaft is the non-threaded part, which is the smooth part between the head and the thread, and the shaft size varies according to the type of the screw. This is the cortical screw, in which there is big head. Cortical screw has big head, and the small shaft. It has a small shaft. This is the cancellous screw. These both are the cancellous screw. This has the bigger shaft as it is partially threaded, so it has bigger shaft and longest shaft, and this is the cancellous screw which has a bigger shaft. So in the cortical screw it has a small shaft, and in the cancellous screw it has bigger shaft, and in the partially threaded screw it has the longest shaft. Functions of the shaft. Shaft provides compression by lagging. Now, threads. This is the threads. So threads. Threads has two diameter. Inner diameter, which is called core diameter. Outer diameter, which is called thread. This is the head. This is the shaft. And this is the thread. And this is the tip. This is the core diameter. And this is the outer diameter. Core diameter is also known as root diameter, and it represents the narrowest part. This is the narrowest part, narrowest diameter of the screw across the base of the thread. The bending and the torsional strength depends on core diameter. Larger the core diameter, stronger the bending rigidity. Thread diameter. It is the outer thread diameter refers to the maximum thread width. The size of the screw are named after the diameter of the screw. If the screw size is 4.5 mm, then its outer diameter is 4.5 mm. And outer diameter affects the pull-out strength of the screw. Wider the outer diameter, larger the pull-out strength. Pitch. This is the pitch. This is the distance between the adjacent thread and the lead. Distance it travels on a complete turn is the lead. Now, tip. This is the tip. Tip is the end on the screw. It engages the pilot hole first. And the types of the tip. This is the blunt tip. You can see the blunt tip. This is the trocar tip. And this is the corkscrew tip. Blunt tip is found in the cortical screw. And this trocar tip is found in the malleolar screw. And the corkscrew tip is found in the cancellous screw. Tip may be modified as self-tapping and self-drilling and self-tapping. For the self-tapping, it has flute. There is the depressed area called the flute for the self-tapping. Self-tapping cortical screw. At the tip of this screw, there are inbuilt tapping device in the form of the flute. But in self-tapping and self-drilling, locking screw is of this type, which has the drill bit. It has drill bit and also the flute for the tapping. Drill bit and the flute for the tapping. Now the types of bone screw. Bone screw is of 4 types. Cortical screw, which is used in cortical bone. Cancellous screw, which is used in cancellous bone. Locking screw, which is used with locking compression plate. Special screw like the Herbert screw, interference screw and the hip screw. Cortical screw. Cortical screw is used in cortical bone. Cortical screw may be used with isolation or along with the plates. Cortical screw is the modification of the machine screw, and the most common size of the cortical screw are the 3.5 mm and 4.5 mm, which is used in the orthopedic implant. 3.5 mm cortical screw means that the outer diameter of the screw is 3.5 mm. Now the difference between 3.5 mm cortical screw and the 4.5 mm cortical screw. 3.5 mm cortical screw means that the outer diameter of the thread is 3.5 mm, and 4.5 mm cortical screw means that the outer diameter of the screw is 4.5 mm. Drill bit. The drill bit used in the 3.5 mm cortical screw is the 2.5 mm drill bit, and in the 4.5 mm cortical screw, drill bit used is 3.5 mm. It is 1 mm less drill bit is used in both. Now for the tap, in the 3.5 mm cortical screw, 3.5 mm, it is of same size. 3.5 mm cortical screw, the tap used is of 3.5 mm. And in the 4.5 mm cortical screw, the tap is used of 4.5 mm. And 3.5 mm cortical screw is used in the forearm bones, humerus and the fibula with a small DCP. 4.5 mm cortical screw is used in the tibia and the femur with broad narrow DCP. It is a big 4.5 mm cortical screw. It is used in long bones like tibia and the femur, comparison to the 3.5 mm cortical screw which is used in the forearm bones, humerus and the fibula. The cancellous screw. Screw is the modified wooden screw. It is used in the cancellous bone, and the size used in the orthopedic of the cancellous screw are the 4.5 mm and 6.5 mm. 4 mm means that the outer diameter of the screw is 4 mm. Cancellous screw 4 mm and the 6.5 mm. It can be partially threaded or it can be fully threaded. It can be cannulated or it can be non-cannulated. In fully threaded, it can also be cannulated and the non-cannulated. In cannulated screw, we can pass the guide wire and can perform the close reduction. There is no need to open the fracture, or we can percutaneously fix the fracture. When partially threaded screw is used, partially threaded screw provides compression across the fracture site by pulling or pushing the small bone fragment towards the large bone fragment. Partially threaded, as it is partially threaded, this has no threads at the shaft. No threads at the shaft. The threaded parts gets engaged to the bone across the fracture line. It gets compressed. When this threaded part engaged to the bone across the fracture line, then it gets compressed. Length of the screw must be chosen because the threaded part of the screw lies fully within the opposite bone fragment. Here we can see that this is the threaded part, and this threaded part should lie fully within the opposite bone fragment, and this is the shaft. This is the partially threaded screw, and this is the shaft which is non-threaded, and the washer is used to provide sinking of the head into the bone. And the partially threaded screw provide compression. Whenever we require compression between the fracture fragment in the cancellous bone, we use partially threaded cancellous screw. Here we can see that fracture fragments are pulling each other. When to use the fully threaded screw? As it is fully threaded, it provides the better purchase and strong hold. It provides a strong hold. So when good hold is needed after compression is achieved by the 1 or 2 partially threaded cancellous screw, we use the fully threaded screw. For compression, we use the partially threaded, and for the good hold, we use the fully threaded. Advantage of the cannulated screw. As it is cannulated, we can pass the guide wire through this, and through the guide wire we can perform close reduction and percutaneous fixation with cancellous screw. And it can be used in the neck of femur fracture. Here the neck of femur is fractured, and we have used 3 partially threaded cannulated cancellous screw. This is the partially threaded. There is no thread in the shaft. And to use the cannulated screw, all equipment must be cannulated, like the drill bit, tap, and the screwdriver. Difference between the cortical screw and the cancellous screw. Cortical screw is the modified machine type. Cancellous screw is the modified wood type. Cortical screw has a small threads diameter, and it has lower pitch, and it is used in the cortical bone, and pre-trapping is required. But in cancellous screw, it has larger thread diameter, it has higher pitch, and it is used in the cancellous bone, and tapping is not done. Most commonly size used in the orthopedic of the cortical screw is the 4.5 mm and 3.5 mm, and but that of cancellous screw is the 6.5 and the 4 mm. And the cortical screw has large head, and usually the partially threaded and the cannulated screw are the cancellous screw. Let's identify some screw. As we can see that this is the large size. So this is fully threaded. These both are the fully threaded. So fully threaded, and this is the large size. So 6.5 mm fully threaded, and this is the cancellous screw, and this is the cortical screw. Cortical screw has big head. And also we can see the pitch. cortical screw has lower pitch and a smaller thread diameter. So this is the cortical screw has a smaller pitch and the pitch of the cancellous screw is larger. Here this is the pitch. Pitch is the distance between the adjacent thread. This both is of small size. These both are partially threaded, but in the tip we can see there is the trocar tip, and trocar tip is found in the malleolar screw. So this is 4 mm partially threaded cancellous screw. This is cancellous screw as it has a small head, but this is the 4.5 mm malleolar screw as it has trocar tip. This is the fully threaded as it has big head. It is the cortical screw. This is also fully threaded but small head, so the cancellous screw. So 4.5 mm cortical screw, because cortical screw is found in the two sides, 3.5 mm and 4.5 mm. And cancellous screw is found in the 4 mm and the 6.5 mm. But this is looking small, so 4 mm cancellous screw, and it has a small head, so it is cancellous screw, and it has big head, so it is cortical screw. This is also the fully threaded. This is a big head, so the cortical screw, small head, so the cancellous screw is looking small, so 3.5 mm, and this is the 4 mm cancellous screw. Now let's see the locking screw. Locking screw is used only with the locking plates. It is threaded in its countersink. This is the countersink in which it is threaded. This threaded head locks into the plate and provides angular stability. This threaded head locks into the plate and provides angular stability. We can see the threaded countersink in the locking screw. This is the combi hole of locking compression plate. The threaded part, this is the threaded part, and the threaded part accommodates the locking screw. Now some special screw. The hip screw. It is used as a component of dynamic hip screw in the intertrochanteric fracture fixation. This is the hip screw, and this is the X-ray showing hip screw. This is the hip screw as the part of ones used for internal fixation of this is the dynamic hip screw plate, and this is the screw, and this is the hip screw. Herbert screw. It is threaded at both ends. We can see the thread at the both end, and it is cannulated. We can see the guide wire is passed, so it is cannulated for percutaneous insertion, and it is used for scaphoid fracture fixation. This is the Herbert screw, and X-ray of the scaphoid fracture fixed with the Herbert screw. Interference screw. It is used for graft fixation in anterior cruciate ligament reconstruction. This is the interference screw, and this is the X-ray showing interference screw. This is the interference screw used for fixation of graft in the anterior cruciate ligament reconstruction. Now the process of screw insertion. Screw is used in combination with plates or in isolation, and the device required for screw insertion is the drill bit, depth gauge, tap, and the screwdriver. This drill bit is used to make a pilot hole for the screw, and usually 1 mm smaller than the size of the screw. This is the drill bit used to make a pilot hole, and if we have to make a it is used 1 mm smaller than the size of the screw. If the screw size is 3.5 mm, then the drill bit used is 2.5 mm. Depth gauge. This is the depth gauge. It measures the length of the screw required. If the screw is of 4 mm or smaller, then 3.5 mm depth gauge is used, and if the screw is larger than 4 mm, then 4.5 mm depth gauge is used. This is the depth gauge. Bone tap. Bone tap is used to cut threads for the screw. As the screw had threads, it is used to cut threads for the screw. Should be of the same size of the thread diameter of the screw. If the screw is 4.5 mm, then the bone tap should be 4.5 mm. This is the screwdriver. The tip of the screwdriver should match with the recess of the screw head. The steps of the screw insertion. First step is the drilling. We do the drilling by the device drill bit. We measure the length by the depth gauge. We do tapping by the tap, and we do the screwing in by the screwdriver. This is all about the screws used in the orthopedic implants. You can find these notes in the Telegram, and the links are given in the description. Thank you.